Welcome you all. Today we will discuss about the problems regarding the impact of a jet. So first problem will be like this, and the water is flowing through a pipe at the end of which a nozzle is fitted. So there will be a pipe and at the end of which a nozzle is fitted, and the diameter of the nozzle is 100 mm, and the head of water at the center of the nozzle is 100 meter. So the head is 100 meter and the diameter of nozzle is 100 mm. Find the force exerted by the jet of water on a fixed vertical plate. So there will be a fixed vertical plate and jet of water is flowing, strikes the fixed plate. Uh, and we need to find the force exerted by the jet of water on this particular plate. So this is the problem. So the given data are a diameter is 100 mm. So converting it into meter. So 0.1 meter, and area of cross section will be obtained from the equation pi by 4 d square. So pi by 4 into zero point 0.1 square gives 7.85 into 10 raised to minus 3. 7.85 into 10 raised to minus 3 meter cube will be the area, and a head of water is given as 100 mm. So from this head of water we need to find the velocity with which just strikes the plate. So theoretical velocity we need to find. For finding the velocity, the data given is coefficient of velocity CV is equal to 0.95. So from these values we can find the actual velocity. Actual velocity will be obtained from the equation CV is coefficient of velocity into root 2 GH. So H will be 100 meter. H is 100 meter, head of water 100 meter. From this equation we will get the actual velocity with which jet is flowing. So but we need to find the theoretical velocity for substituting in this equation rho a v square, which is the force exerted. Rho a v square is the force exerted by the jet. Force exerted by the jet on the plate. So in order to find force exerted by the jet, so we need to find the velocity v, which is a theoretical value. So how will you find theoretical velocity? From this equation, CV is equal to V actual divided by V theoretical. So actual velocity to theoretical velocity. From this equation, we will obtain theoretical velocity value. V theoretical is equal to V actual divided by CV. Substituting the values, value of V actual as we obtained earlier, 42.0755 divided by 0.95. So this will give the velocity. So the velocity, theoretical velocity will be 44.29. Substituting in the equation, rho a v square is the force exerted by the jet when it is flowing in the x direction. So rho is the density of the water, which is 1000, and a is the area of the nozzle. A is the area, and v is the velocity with which jet strikes the plate. So we have obtained all these values. I'm substituting in these values in the equation, and we will get a final answer as 15,398.5 Newton. This is the force exerted by the jet on the plate. Okay. So moving to the next question. So here the question is a jet of water. So there will be a jet of water of diameter 50 mm. Here the diameter of jet of water is 50 mm, which strikes on a fixed plate in such a way that the angle between the plate and the jet is, so the angle between the plate, so the plate is placed at an angle. So this is the plate, so it is placed at an angle with the jet. So the jet of water is flowing like this. It will strikes the plate and moves like this. So this will be the axis, So this angle is theta. So the value of theta is 30 degree. 30 degree is the value of theta. So the force exerted in the direction of jet is, so here the value of force is given. Force exerted Fx is given in the direction of jet, means in the direction of jet is x direction. So in the direction of jet the force is given, it has 1471.5 Newton. So the force in the x direction is given. So we need to find the rate of flow of water. So rate of flow, here we are finding out the rate of flow of water. Rate of flow of water means what? Q, discharge. So we need to find the rate of flow in meter cube per second. So this is the question. So the given data are diameter of the jet, angle with which the jet makes with the plate, and the force in the x direction. So we are moving to the solution. So it is given that A is equal to area. From the diameter we can find area of the jet. Area of the jet will be obtained from pi by 4 d square, substituting the value of d as 0.05. It is given as 50 mm, so 0.05 meter. So pi by 4 into 0.05 meter square, 0.05 square. So we'll give an value of 1.963 into 10 raised to minus 3 meter square. So the meter square is given. So we know that the f of x means the force exerted in the direction of jet, f of x. So it will be rho a v square sine square theta. Rho a v square sine square theta. So in order to find the rate of flow, we need to find the velocity with which jet is moving. So the rate of flow will be A into V. Area into velocity is the rate of flow, rate with which jet or water is coming out from the nozzle is the rate of flow. So our main aim is to find the rate of flow. In order to find rate of flow, we need the value of A, which is already there, and we need to calculate value of v. So from this equation f of x is equal to rho a v square sine square theta, we can find the value of v. So from this equation we are finding the value v. So v will be obtained from this equation. So v square is equal to f of x in the left side divided by all other terms will come at the denominator. So rho a into sine square theta. So here all the values are known. F of x is already given, density is 1000, area is already obtained, which is 1.963, and the sine square theta value is equal to 90 degree, which is given in the problem itself. Theta is equal to 30 degree, which is given in the problem itself. So substituting all the values, we will get the velocity as 54. V square is equal to 2998.471, and we are finding the root. If v square is there, v square is equal to 2998.471. So v square is there. So in order to find, we are taking the root of 2998.471. So the value will be 54.75 meter per second. So once we get the velocity value, we can obtain the rate of flow, which is q. Q is equal to a into v. So the final answer will be 0.1 107 meter cube per second. So this is the rate of flow. That means the water is coming out from the nozzle at the rate of 0.107 meter cube per second. Welcome to the next session of the impact of jet. So in the last class we had discussed about the plate which is stationary and a jet of water is striking the stationary plate. So in this class we are discussing about a moving plate. So here we are considering a moving plate and the jet of water is striking on a moving plate. So the first case is force exerted by the jet on a vertical flat moving plate. So the first case is the jet striking on a vertically placed moving plate. So it is not fixed and the plate is moving with a velocity u. The plate is moving with a velocity u and the jet of water coming out from the nozzle is with a velocity v. So v is the velocity with which jet of water coming out from the nozzle and u is the velocity of the plate. So the water is striking the plate at a relative velocity. Since the plate is having some velocity, so the water will strike the plate at a relative velocity only, not with the same velocity. So the relative velocity of the jet before striking the plate is v minus u. After striking the plate, the water will move upward direction or downward direction. That is, it is moving in the y direction only. So there will be no relative velocity component in x direction after striking the plate. So mass of fluid striking is equal to mass of fluid striking will be. So earlier the mass of fluid, when the plate is stationary, the mass of fluid striking will be rho a b. But in this problem, the plate is moving with a velocity u. So the mass of fluid striking will be mass per second striking will be rho a into v minus u because the fluid is striking the plate at a relative velocity. So rho a v minus u is the mass of fluid striking the plate. So, in order to find force exerted by the jet in the x direction, the equation will be mass per second into initial velocity with which jet strikes the plate minus final velocity. So, mass per second will be, as I discussed earlier, the mass per second will be rho a into v minus u. The initial velocity with which jet strikes the plate is v minus u, and there will be no final velocity in the x direction. In the x direction, after striking the plate, there will be no velocity since the jet is moving in the vertical direction only. So the final equation will be multiplying rho a v minus u into v minus u gives rho a v minus u whole square. Since there is some movement in the x direction due to the force f of x, due to this force in the x direction, there will be a movement in the x direction. The plate is moving in the x direction. So in this case there will be the component for work done. So work done will be f of x into work done will be f of x. Normally work done will be the force exerted into distance traveled. So here we are taking it as u. So the distance traveled per second. So work done per second, we are obtaining work done per second. So here the equation will be work done per second. Since the term u is meter per second, so we are obtaining work done per second. Rho a v minus u whole square is the f of x and u is the movement in the x direction. So the unit will be Newton meter per second or watts, Newton meter per second or watts. So rho A V minus U whole square into U gives the work done per second in the x direction. The efficiency of the particular setup will be output by input. Output is the work obtained from the particular device is output, and the input is the input energy we are giving is the kinetic energy of the jet. So kinetic energy of the jet is the input. Normally efficiency will be output by input, and the output is the work from the given setup. So the work done per second divided by kinetic energy. Kinetic energy is the given input. Kinetic energy of the fluid is the given input. So work done per second is equal to f of x into u, and the kinetic energy is half. Kinetic energy will be half m v square. Half m v square. Okay. So what is m? M here will be rho a v. M is rho a v, mass of water coming out from the jet. So mass of water coming out from the jet, it is here we are taking rho a v, not relative velocity, because we are not considering the mass of water striking the plate. Here we are considering the mass of water issuing from the jet, that is the input. So that is why it is taken as rho a v. So f of x into u divided by half into rho a v into v square gives the efficiency. So the equation will be like this: f of x into u divided by half rho a v cube is the efficiency of this particular setup. So the next condition is that the force exerted by a jet on an inclined flat plate moving in the direction of a jet. So there will be a flat plate which is inclined at an angle of theta with the jet. So theta is the inclination of the plate with the jet. So the normal component of velocity, the velocity of water is like this. Normal component of velocity is v cos 90 minus theta, that is v sin theta. Since the plate is moving with a velocity, u, so the jet of water is striking at a relative velocity only, that is v minus u, and the cos 90 minus theta is the normal component of velocity. The velocity is v, this is theta. So this portion is 90 minus theta. So the normal component will be v minus u into cos 90 minus theta. So f of x will be in the direction of the jet. F of n will be the normal component of the fluid striking the plate, and f of y will be the y component of the jet force, y component of the force. So the relative velocity of the jet before striking the plate is v minus u. Mass of fluid striking per second is equal to mass per second is equal to rho a into v minus u. So the mass of water striking the plate, we are considering the mass of water striking the plate. Since the water striking the plate is at a relative velocity, so we are taking it as rho a into v minus u. So in order to find the normal component of force, first of all we are finding the normal component f of n. We are finding the normal component of force acting on the plate. So mass per second into initial velocity minus final velocity gives the normal component of force. So mass per second will be rho a into v minus u, and initial velocity with which a jet strikes the plate will be v minus u sin theta. So how will you obtain v minus u sin theta? So here the normal component will be v minus u into cos 90 minus theta. Cos 90 minus theta will be sin theta. So the v minus u into sin theta gives the initial velocity with which jet strikes the plate minus 0. 0 is that there will be no normal component after striking the plate. So there will be no normal component after striking the plate. So the value will be 0. So 0 is the value. So the final equation will be rho a v minus u whole square into sin theta. So f of x is equal to f of n cos theta. So f of x is the x component. Component. We are finding the x component of the force. So f of x is equal to f of n cos theta. F of n cos theta. F of x. So normal component, we know the normal component value. So this is theta. So this value is theta. So normal component is not. So x component will be f of n cos theta. Y component will be f of n sin theta. So this is y component. Okay. So f of x cos theta is the cos 90 minus theta. Sorry, cos 90 minus theta. So f of n sin theta. So the equation, so here the value is 90 minus theta. So it will become f of n sin theta. So rho a into v minus u whole square into sin square theta is the equation. Why sin square theta? We know that f of n will be rho a v minus u. This is 90 minus theta. So it will become sin theta. So rho v minus u whole square into sin theta into cos 90 minus theta will be sin theta. So the final equation will be, this term will be sin square theta. So the equation becomes rho a into v minus u whole square into sin square theta. So the y component is equal to f of n into sin 90 minus theta. Sin 90 minus theta. So f of n cos theta. So the term will be instead of sin theta, here the term will be cos theta. So the equation will be rho a v minus u sin square theta, rho a v minus u whole square into sin theta cos theta. So this is the y component of the force, normal force, and f of x will be the x component. So work done per second. Work done per second will be calculated if there is any component in the x direction. Not the component if there is any displacement in the x direction due to the force in the x direction. So in the x direction the force will be f of x, and there will be displacement in that direction which is given as velocity term, which is meter per second. So f of x into u gives the work done per second in the direction of the jet, or work done per second. Okay. So efficiency is equal to output by input is equal to work done per second divided by kinetic energy of the jet. Output is work done per second and input is kinetic energy of the jet. Output will be f of x into u, which is the work done, and input will be half mv square. So we know that m is equal to rho a v. So the term will be rho a v into v square. So f of x into u, efficiency term will be f of x into u divided by half into rho a v into v square. So this is the term of efficiency for this setup. Okay.